Hi folks, welcome back to my channel Tech-IOT. I hope all of you doing well. So today we are going to see IoT levels and deployment templates. IoT level comprises the components that are device, resources, controller services, database, web services, analysis component and application. First one is the device. IoT device allows identification, remote sensing, actuating and remote monitoring capabilities. Resources. Resources are a software component of IoT devices for accessing, processing and storing sensor information or controlling actuator connected to the devices. Controller service. Controller service is a native service that runs on the device and interacts with web service. Controller service sends data from device to web service and receives command from the application for controlling the device. Database. Database can be either local or in the cloud and store the data generated by the IoT devices. Web services. Web services serve as a link between IoT device, application, database and analysis component. Web service can be either implemented using HTTP REST principle or using WebSocket protocol. REST services are stateless in nature. Each request contains all information needed to process it. Requests are independent of each other. WebSocket on the other hand is stateful in nature, where server maintains the state and aware of all connections. REST service operates on HTTP and it is a unidirectional. WebSocket is a bidirectional protocol that allows both client and server send message to each other. REST service follows the request-response communication model where client sends request and all server responds to the request, where WebSocket on the other hand allows full duplex communication between client and server. REST service each HTTP request involving setting up new TCP connection, where WebSocket on the other hand involves a single TCP connection over which the client and server communicate in full duplex mode. REST service operates on HTTP and each request is independent of others. Thus each request carries HTTP headers, which is an overhead. Due to overhead HTTP headers, REST is not suitable for real-time application. WebSocket on the other hand does not involve overhead of headers. After the initial handshake, the client and server exchange message with minimal frame information. Scalability. REST service requests are independent and no state information needs to be maintained by the server. Thus both horizontal and vertical scaling solutions are possible for REST services. Where WebSocket is horizontal scaling can be cumbersome due to stateful nature. Since the server maintains the state of connection, vertical scaling is easier for WebSocket than horizontal scaling. Analysis component. The analysis component is responsible for analyzing the IoT data and generate results in the form of which are easy to understand for users. Application. IoT application provide the interface that user can use, control and monitor the various aspects of IoT system. IoT level 1. Let us consider example for home automation. The system consists of single node that allows controlling the light and appliances in a home remotely. The devices used in this system interface with light and appliances using electronic relay switches. The status information of each light and appliances is maintained by a local database. REST service deploy locally allow retrieving and updating state of each light. The controller service continuously monitors the state of each light and triggers the relay switch accordingly. The application which is deployed locally has a user interface for controlling the light or appliances. Since device is connected to the internet, the application can be accessed remotely as well. IoT level 2. Data is stored in the cloud and application is usually cloud-based. IoT level 2 systems are suitable for solutions where data involved is big. However, the primary analysis requirement is not computationally intensive and can be done locally itself. Let us consider example for smart irrigation. The system consists of single node that monitor the soil moisture level and controls the irrigation system. The device used in this system collects soil moisture data from sensor and controller service continuously monitor the moisturizing level. If the moisturizing level drops below threshold, the irrigation system is turned on. For controlling the irrigation system, actuators such as solenoid valves can be used. The controller also sends the moisturized data to the computing cloud. The cloud-based REST web service is used for storing and retrieving moisturized data which is stored in cloud database. Cloud-based application is used for visualizing and monitoring levels of time which can be help in making decisions about irrigation schedules. IoT level 3. Let us consider example for IoT level 3 is system for tracking package handling. The system consists of single node that monitor the vibration levels for a package being shipped. The device in this system uses accelerometer and gyroscope sensor for monitoring vibration levels. The control services send sensor data to the cloud in real time using WebSocket services. The data is stored in a cloud that also visualized using cloud-based application. The analysis component in the cloud can trigger alerts if the vibration levels become greater than threshold. The benefit of using web service instead of REST service in this example, sensor data can be sent real time to the cloud. Moreover, cloud-based application can subscribe to the sensor data feeds for viewing the real-time data. IoT level 4. Let us consider example for noise monitoring. The system consists of multiple nodes placed in different locations for monitoring noise level in the area. The nodes in the example are equipped with sound sensor. Nodes are independent of each other. Each node runs its own controller services that send to the data to the cloud. The data is stored in a cloud database. The analysis of data collected from number of nodes is done in the cloud. A cloud-based application is used for visualizing the aggregate data. IoT level 5. Let us consider example forest fire detection. The system consists of multiple nodes placed in different locations for monitoring temperature, humidity and carbon dioxide level in the forest. The end nodes in the example are equipped with various sensors such as temperature, humidity, CO2. The coordinator node collects the data from the end nodes and acts as a gateway that provides internet connectivity to the IoT system. The controller service on the coordinated device sends the collected data to the cloud. The data is stored in a cloud database. The analysis of data is done in the computing cloud to aggregate the data and make predictions. A cloud-based application is used for visualizing the data. Next one is the IoT level 6. IoT level 6 system has a multiple independent end nodes that perform sensing or actuation and send data to the cloud. Data is stored in a cloud application is cloud based. Let us consider example for weather monitoring. The system consists of multiple nodes placed in a different location for monitoring temperature, humidity, pressure in the area. The end nodes are equipped with various sensors such as temperature, humidity, pressure. The end node sends the data to the cloud in real time using WebSocket service. The data is stored in a cloud database. The analysis of data is done in the cloud to aggregate the data and make predictions. The cloud-based application is used for visualizing the data. I hope you like this video, and if you like, then subscribe my channel and hit the bell icon for regular updates. And if you have any doubt, please let me know in comments. In next video, we are going to see various protocols in IoT. Thank you for watching. Take care. Bye bye. See you soon.